And today's section is going to be all about finding arc measurements. And so it's going to be a good idea to go ahead and identify some things real quick. So let's draw a circle. So here's going to be our circle. And we're going to go ahead and mark the center of the circle as C. And we're going to draw two radii coming out from this circle to form an angle like this. And we're going to label this one A, this one B, and we need to put a point D somewhere on the back side of this angle. This angle that we just drew, that almost triangle ABC type shape, is going to be called a central angle. And a central angle of a circle is an angle whose vertex is on the center of the circle. So we can go ahead and highlight that here. This in green is going to be our central angle. And notice that there's an interior to this central angle and an exterior. And the interior of the angle, and you always know what the interior is because it is the acute side or the smaller side. Like if you have a central angle that's like this, it's going to be the smaller bit. Will form what is called a minor arc. And the exterior will form a major arc. So we have minor arc, we have a major arc. I'm going to highlight our minor arc in red. So that's this interior bit. And we can write that down. That's our minor arc. And we can go ahead and label our major arc here in blue. And so our major arc is going to be that bit in blue. And we have to go ahead and do a bit of a naming convention. So our minor arc is going to just be called arc AB, and we can abbreviate that using AB with an arc over the top, like a little rainbow. And then major arc is going to be called ADB, because if we just named it AB, it would be a little bit confusing. And then finally, a semicircle is when the endpoints of an arc are the diameter. All right, so here's all the different types of arcs we're going to be working with. I just had a cat run across my desk, so that's lovely. Why don't we go ahead and start talking about how to measure some arcs, do some arc measurement. All right, so let's draw a circle again over here. Oh, I need to fix a problem. I have a cat running all over the place. And I'm going to go ahead and shut the door real quick. Sorry about that. Normally the cat doesn't do too much, but when she starts crawling on top of my computer monitor, we have a bad time. So the measure of minor arc is the measure of the central angle. And so if I were to draw a circle over here, that's an oval. Our circle over here, and we go ahead, we put our center here at C, we draw our central angle here, and we're going to call this ABC or ACB. And the measure of angle ACB is going to be 50 degrees. What this just said is that the measure of a minor arc is the measure of the central angle. And remember, our minor arc is going to be from A to B right here. So the measure of arc AB is going to be equal to 50 degrees. And from that, the measure of a major arc is going to be 360 degrees minus the minor arc. So we can highlight our major arc here, going all the way around. That's going to be our major arc, and we're going to say that the measurement of ADB, that arc, is going to be equal to 360 degrees minus 50 degrees, or 310 degrees. So real quick, I'm going to draw a circle now, and we're going to find some different arc measurements on that. So here's our circle. We're going to have a center of this circle P. I'm going to go ahead and we're going to draw a diameter across here. And then we're also going to give another radius coming off of there that is equal to 110 degrees. It would be helpful to probably have some labels. So we're going to have T, P is our center, and R over here. And then S is going to be out there on the outside. And we want to find a couple of different measurements. First, we want to find the measurement of arc RS. Second, let's find the measurement of arc RTS, so going backwards from RS. And then finally, let's go ahead and find the measurement of RST. So we're going to go ahead and do each one of these in a different color. So we're going to start with measurement of RS. We're going to do that in yellow. And so if we find R to S, that's going to be that guy right there. And it's going to be directly correlated to this interior angle, which is equal to 110 degrees. Next, let's do RTS here in orange. So we're going to go to R, all the way around to T, all the way around to S. Not my best work, but notice that that's the other side of our yellow, and we know a circle is 360 degrees. So we're going to take 360 degrees minus our yellow bit of 110 degrees, and that's going to be equal to 250 degrees. And then finally, why don't we take a look at RST? So that's going to be this bit all the way around to there. Notice that this is a diameter, and so a diameter is a straight line, which is equal to 180 degrees. So this angle measurement is going to also be 180 degrees. All right. Next, we're going to go ahead and talk about adjacent arc. And two arcs are adjacent when they intersect at exactly one point. And we're going to use adjacent arcs in postulate 10.1. And remember, postulate is a given fact to be true. You don't have to prove it. And so this is going to be our arc addition postulate. And our arc addition postulate states the following. If we draw a circle here, and we go ahead and put a dot here at A, point here at B, and then a point here over here at C, and then say we have arc AB here in red, and then we're going to have arc BC here in blue, that the measurement of the entire arc ABC, so the blue and the red, is equal to the measurement of our red arc AB plus the measurement of our blue arc BC. So you can add arcs together, which makes sense. And once again, this green bit is going to be the green bit all the way around there. So with that piece of information, now let's go ahead and find some more arc measurements. So we're going to go ahead and draw a circle here. We're going to put the circle center here at R, and we have our first angle, which is going to be right here. Our second one is going to come off over there, and then finally we have our third one right here, and this is not a diameter right there. In my original drawing, it looks more like a diameter. So we have 40 degrees on the first one, 80 degrees on the second one, and then 110 degrees on the last one. And let's go ahead and put some other points here. So we have E, F, G, and H, and we want to find first the measurement of GE. Second, let's find the measurement of GEF. And then finally, let's go ahead and find the measurement of arc GF. All right, so let's first identify GE. So we're going to go from G all the way to E. We're going to do that in yellow. Notice we have one bit here that's equal to 40 degrees. We have another bit here that's equal to 80 degrees. So we're going to take 40 plus 80 degrees to get 120 degrees. Next, let's do GEF. So we're going to go from G all the way out to E, all the way out to F. And so we're just going to take our 40 plus our 80, which we already know to be 120 degrees, and then also add in plus 110 degrees. And that, of course, is going to give us 230 degrees. Finally, let's find the arc of GF. So we're going to go backwards here. And notice that GF is the minor arc to the orange arc of 230 degrees. So we just need to take 360 degrees minus our 230 degrees to get 130 degrees for our last measurement. So that one is 130. Our yellow arc is 120 degrees, and I know that kind of got lost there in the orange, so we'll redraw that in. And then our orange arc is 230 degrees. So now that we have the basics of arc measurements covered, I want to introduce now a couple of theorems. So we're first going to get started here with theorem 10.3. And theorem 10.3 is going to be the congruent circles theorem. And it states the following: two circles are congruent if and only if they have the same radius. which makes kind of sense. If you draw two circles here and they're both the same size, then you would imagine that their radius on both would be congruent. Pretty straightforward. Next, let's do theorem 10.4. And this theorem is going to be called the congruent central angle theorem. And the congruent central angle theorem states the following: two minor arcs are congruent if and only if their corresponding central angles are also congruent. And so if we draw a circle here and we take two diameters and intersect them, like so, then you know that vertical angles here are going to be congruent. So we know that this side and that side are congruent to one another, so this arc must be congruent to that arc. And so now, with this pieces of information, I'm going to draw some different circles here. The first one is going to look like this. Come on, make a circle. There you go. We're going to cut this circle in half, and then we're going to draw two bits out of the center like so. The next circle, actually we can finish the first one. So each one of these is equal to 80 degrees. And we have these two red bits right here. And my question is, are the red parts congruent? Are the red arcs congruent? So next we're going to have a set of concentric circles like that. Oops, messed that up. Then I put that right there. Go straight up. Go straight over. This is going to be a 90-degree angle, and I want to know, is this arc congruent to this arc? And then finally, we're going to have two circles like this. Need to go ahead and adjust the center point on that second circle. It's not very center-like. Oops. Man, I'm really struggling on this last one, so it's giving you plenty of time to think on that. Those first couple. Those are both 97 degrees. That, and we want to know, are these two arcs congruent? Right there. So let's look at this first one. We have these theorems up here that says that two minor arcs are congruent if and only if the corresponding central angles are also congruent. And since 80 degrees is always equal to 80 degrees, these two are going to be congruent. So thus, the two red arcs must also be congruent. Next here, both of these arcs have a measurement of 90 degrees, but the circles themselves are not congruent. And remember, to be congruent, the figures have to have the same angle measurement as well as the same length. And this bottom circle has a significantly smaller length than this top circle. If you were to imagine taking this and drawing it out as a straight line, that one would be about that long, and this one would only be about that long. So because of that, these two are not congruent. And then finally, we have two separate circles here. The radii are both congruent, so theorem 10.3 is going to tell us that these two circles are indeed congruent. They both have the same angle measurement of 97 degrees. So thus, these two are, yes, indeed, congruent. And with that, I have one last thing I want to tell you. This has all been leading up to a very important theorem, theorem 10.5, which is going to be called the similar circle theorem. And it states that all circles are similar. All right, that's all I got today.